Hi guys. So far you've learned that specific heat refers to the amount of energy required to raise the temperature of 1 kilogram of a substance by exactly 1 Kelvin. Now what this is really saying is it's just referring to the amount of energy that is required to raise the temperature of a substance, all right? And a substance may have a different specific heat. All right, water has a specific heat of 4,186, I believe. Yeah, the specific heat of water is 4,186. And the specific heat of aluminum is 897. All right? Since the specific heat number for water is higher than the specific heat number for aluminum, it means that it takes more energy to heat up water than it does to heat up aluminum. All right? The aluminum would get hot faster than the water would, okay? Because it takes a lot more energy to heat up the water. It would take more time to heat up the water. That's why the aluminum would take less time and it would be hot sooner. All right, so you can use this value for specific heat to actually determine how much energy is required to either raise the temperature of a substance or to lower the temperature of a substance, okay? So the equation looks like this. It is energy equals specific heat times mass times temperature change. All right, for this, you're talking, for specific heat, mass, and temperature change, you're talking about a particular substance or a particular object, all right? You could be talking about aluminum. So you put the specific heat of aluminum times the mass of aluminum times whatever the temperature change was, meaning whatever the difference between the final temperature and the initial temperature was, would be your temperature change. Because the difference would tell you how much that temperature went up or went down. All right? So, we are going to get some practice with this equation. Take a look over here. So, this is asking, how much energy must be transferred as heat to 200 kilograms of water to raise the water's temp from 25 degrees Celsius to 37 degrees Celsius? All right, so imagine we have maybe a bathtub full of water, and that bathtub, the bathtub can hold this mass of water. All right, so there is 200 kilograms of water in that tub. All right, that's how much the water weighs inside that tub. And we want to raise that water's temperature from 27 degrees Celsius to 37 degrees Celsius. And we want to know how much heat energy that would take. All right? So what we're going to do is we're going to use this equation. Notice how it's asking how much energy. All right? This equation allows you to solve for energy. Okay? In this situation, we don't know what the energy is. That's what we're being asked. So under this, I'm going to put a question mark. We don't know what that is. Do we know the specific heat of water? Well, yeah, we do. It's actually in your slideshow, and I just told you it. It's 4,186. All right? Now, another thing that I want to mention, and this wasn't mentioned in the slideshow, but I want to point out that specific heat has a certain unit that you have to use when you write the number, or after you write the number for the value. So the specific heat, the unit for specific heat is joules divided by kilograms times Kelvin. And if you think about it, this sort of makes sense as a unit for specific heat, because specific heat is the amount of energy that is required to raise the temperature of 1 kilogram of substance by 1 Kelvin. All right? So if you memorize the definition of specific heat, you'll always know the unit for it because it makes sense. energy, mass, temperature. All right? Okay, so that's the specific heat of water. Now we want to multiply it by the mass of the water from this particular situation. All right, so in this situation, we have 200 kilograms of water. So that's what goes under the mass section, 200 kilograms of water. And now the very last thing that we want to put in before we multiply these numbers to get our answer, we want to find the temperature change, all right? We want to find the amount, the value for how much the temperature went up, all right? So we have two numbers here. We have a starting value of 25 and the temperature increased to 37 degrees Celsius. In order to find out how much the temperature increased by, all you have to do is subtract those two numbers. You just do 37 degrees Celsius minus 25 degrees Celsius. All right, so you just subtract these two numbers. I'm going to do that right over here. Let me make sure you can see it on your screen here. All right, so you take the larger number and subtract it from the smaller number. So 37 degrees Celsius minus 25 degrees Celsius. All right, 37 minus 25 is 12. So this equals 12 degrees Celsius. So that's the temperature change. Now you're probably noticing, or I hope you're noticing, that this temperature scale is in degrees Celsius. But when we talk about specific heat, or when we talk about these equations in general, we want to have our temperature changes in kelvins. Well, it turns out that even though 25 degrees Celsius and 37 degrees Celsius is a different number than what would be represented in Kelvin, you actually get the same difference here. You'll still get 12, all right? So let's take a look at this. So 37 degrees Celsius is 310.15 Kelvin. So this is same thing as saying 310.15 K. All right, let me just make that point a little lower. All right, so 310.15 K minus, and then 25 degrees Celsius is the same thing as 298.15 Kelvin. So minus 298.15 Kelvin. All right, so 310.15 K minus 298.15 K is 12 K. All right, it's the same difference, it's just a different scale. All right, it's the Kelvin scale versus the Celsius scale. So there's different numbers, but the difference between those numbers is the same. Okay, so what do we have here? Well, we have our very last value that we need in order to solve this problem. So we need the temperature change, and we have it. Temperature change is 12 K. All right, and now all we have to do is calculate it. On your calculator, you do 4,186 times 200 times 12. All right, it'll look like this. 4,186, excuse me, let me re-enter that, 4,186 times 200 times 12. All right, and you get 10,046,400. Okay, for your answer. All right, let me make sure this is on the screen. All right, so that would equal 10,046,400. So 10,046,400. All right, And now comes into question, what will our units be? Okay, so for our units, let's take a look here. We can eliminate some things. So we can eliminate kilograms here. We have kilograms on top, on bottom, so we can eliminate that. We can eliminate the value for Kelvin, which leaves us with units in joules. Now you probably already knew that because we have learned that energy is measured in joules. All right, so what we've done here is we've solved this equation. It's asking how much energy must be transferred as heat to 200 kilograms of water to raise the water's temp from 25 to 37. We used our energy formula and we found the amount of energy required. It takes 10,046,400 joules to raise 200 kilograms of water from 25 degrees Celsius to 37 degrees Celsius. All right, go ahead and click on the next slide of your slideshow.